Alright everybody, here are notes for lesson 3.5, rational functions, graphs, applications, and models. So a rational function is in the form f of x equals p of x over q of x, where p of x and q of x are polynomial functions, where p of x does not equal 0 as a rational function, because remember the denominator of a fraction cannot be 0. Okay, here's what the reciprocal function is going to look like. So if it's in the form 1 over x, it's going to be in the first quadrant and the third quadrant. The domain is negative infinity to 0, union 0 to infinity. And then the range is the same thing. Negative infinity to 0, union 0 to infinity. And it decreases on the open interval, negative infinity to 0, and 0 to infinity. It's discontinuous at x equals 0. The y-axis is a vertical asymptote, and the x-axis is a horizontal asymptote. It is an odd function, and its graph is symmetric with respect to the origin. Okay, an asymptote is an invisible line that the graph will get closer and closer to, but will never touch it. Okay, and now here is this rational function. The difference is this is only in the first quadrant and the second quadrant, because it's x squared. So the domain is still negative infinity to 0, union 0 to infinity, and the range is 0 to infinity because it's only above the x-axis. It increases on the open interval, negative infinity to 0, and it decreases on the open interval 0 to infinity. It's still discontinuous at x equals 0. The y-axis is still a vertical asymptote, and the x-axis is a horizontal asymptote. It's an even function, and its graph is symmetric with respect to the y-axis. So like this one, you're going to just use all of your transformation rules. So the negative 4 means that the graph is going to go down 4. The minus 2 means it's going to go right 2. So in the homework, you're just going to say a vertical shift of negative 4 and a horizontal shift of 2. Okay, here are your rules for asymptotes. So if p of x and q of x define polynomial functions, consider the rational exponent f of x equals p of x over q of x, where q of x is still not 0. So the line x equals a is a vertical asymptote, because x equals a is a vertical line, and y equals b is a horizontal asymptote. Okay, to find the asymptotes of a rational function defined by a rational expression in lowest terms. So to find the vertical asymptote, you're going to set the denominator equal to 0 and solve for x. If a is a 0 of the denominator, then the line x equals a is a vertical asymptote. So the other asymptotes, it can have a horizontal one or oblique, but not both. If the numerator has lesser degree than the denominator, then there is a horizontal asymptote at y equals 0. So an example of this is f of x equals x plus 3 over x squared minus 4. The numerator is of degree 1, the denominator is of degree 2, so the numerator is lesser degree. If the numerator and denominator have the same degree, the horizontal asymptote has the equation y equals a to the n over b to the n. So an example of this, so if f of x equals 2x plus 3 over 4x minus 6, they're the same degree. So you do 2 over 4 and you simplify that to 1/2. If the numerator is of degree exactly one more than the denominator, then there will be an oblique or slanted asymptote. To find this, divide the numerator by the denominator and discard the remainder. Set the rest of the quotient equal to y. So this, an example of this, like x squared plus 5x plus 6 over x minus 3. Because 2 is exactly one more than x. Okay, this is how these are going to work. So I'm going to use VA for vertical asymptote, HA for horizontal, and OA for oblique. Alright, so for this first one, to find the vertical asymptote, we have to factor this. So x squared minus x minus 6 is going to factor into x minus 3, x plus 2. Then we're going to set that equal to 0. So x minus 3 equals 0, x plus 2 equals 0. So there's one at x equals 3 and one of x equals negative 2. So the horizontal asymptote, the numerator is of lesser degree than the denominator. So the horizontal asymptote is at y equals 0. There's not an oblique asymptote because there's a horizontal asymptote. Okay, for example 2, for the vertical asymptote, we're going to set x plus 1 equals 0. So it's x equals negative 1. The horizontal asymptote, because they're the same degree, it's going to be y equals 4 over 1, which simplifies to y equals 4. And for oblique, there's none because there's a horizontal one. Okay, and then our last example, for the vertical asymptote, x minus 1 equals 0, so x equals 1. There's not a horizontal one. So for the oblique one, we know x equals 1, so 1 goes on the outside of the box. And then I have 1, 1, 0. So 1, 1, 2, 2. So to find your oblique asymptote, you disregard the remainder. And then we write this as an equation. So y equals x plus 2. Which if we graph that, that would be a diagonal line, which is also called an oblique line. Okay, so this is the last lesson in chapter 3. So you need to finish it and then get ready for your test review.